Hello everyone, welcome back to Archangel RC. Today's topic is the Aggressor, a forward swept wing FPV plane slash cruiser with a wingspan of 1.2 meters, an exceptionally good looking plane, at least in my view. I guess it reminds me of some sort of spacecraft or shuttle or something designed to fly in outer space, and I especially liked the generally thin fuselage and smooth flowing lines resulting from that. Little did I know, at first, of the cost this design would extract from the plane's performance. But let's focus on the good for now. Having a wide body has translated well to also having huge amounts of internal space, which gives a lot of freedom and flexibility in how to arrange electronics and gear, and that is especially true for the battery compartment, which is huge. They weren't quite so generous with the space allocated to install cameras too, but it should be enough for the most part. There is also an option to build this as a twin tractor model. The optional motor nacelles are provided along with the motor mounts, but if you got the plug-and-play package, it comes with a single pusher motor already installed, so I chose to go with that setup. Was not prepared for this one to be twin tractor capable, and also did not see it mentioned anywhere in the product listing. Also loved the huge compartments on the wings, and I did make use of both, including placing the Dragon Link receiver in one of the ESC compartments, since I am not going to have ESCs there. Antennas are out as far as possible from each other and also from other electronics, so hoping there will be no issue with interference. Not that I've ever experienced any, but you know, this is one of those planes I will not be taking apart after each outing, so might as well make use of the provisions for gear separation. Only negative here is that there are no wiring channels provided to these compartments on the wings, so I had to cut them out myself. One thing that I found weird is that whole space behind the main compartment to the motor mount is inaccessible, so basically if you need to replace an ESC or even rotate wires to change motor direction, you have to either cut a hatch or remove the motor each time. Not that you'd be doing this on a regular basis, but still, would have appreciated a hatch there as well, so this space wouldn't be wasted. Plus, it will make it easier to add weight to the tail should you ever need it. Another area of concern for me was the wing to fuselage joint, having a plywood piece only on the wing and no support for the rear wing notch or the carbon spar in the foam of the fuselage to prevent it from squashing it over time. Also, there appears to be some preparation for quick wing connectors to transfer signal and power, but they are not provided with the plane, which would make assembly and disassembly quite tedious. The use of regular bolts to secure the wings also makes it more difficult to pull this apart after every outing, unlike the Zocht planes, which are a lot better thought out in this regard. Also, I am usually quite uneasy about the way factories glue in these plywood pieces, and in fact, after the plane's first landing, where the left wing just caught on some taller grass once it was already on the ground and just turned to the left, the wing came off a little bit and you can see the plywood came undone without much effort really, so not that good of a gluing process applied there. I will have to glue this myself, but for the time being just pushed it back in and put some tape on both wings to hold them in, because apparently the plywood pieces aren't done in the best way. Just something for you to keep in mind when putting the plug-and-play set together. The plastic legs are a very good idea, but their implementation leaves a bit to be desired. Those sharp edges are just waiting to dig into dirt on landings and start ripping foam out. Would it really have been that difficult to implement a solution like what the Atom RC Dolphin has? Plastic covered landing skids should be quite durable and won't dig in. I did try to file the leading edges a bit to make them rounder, so hoping there will be no issues now. The thing I like and appreciate about the rear landing legs in combination with the finger notch for hand launching is the convenience of it all. At first I was afraid the prop would cut me up because it is quite large, 10 inches, but when you throw it properly, it's all good. Also, I replaced the stock 10x5 prop with a 10x7 one, hoping for even more speed out of the plane. I did notice that there is some provision for active canards on the Aggressor and was surprised at least the hardware wasn't included with the plane, unlike the twin tractor motor nacelles, to be something optional to install if one desires rather than to have to DIY it if you need it. And from what I've heard from some people, this plane apparently does fare better with such installed, though I will skip this for the time being. So, in terms of gear for this plane, I went with a Matic F765 wing in the center of it all and the new Dragon Link 915 MHz radio system. And I also set up the Mavlink telemetry to be output to the receiver so I can use the Dragon Link's telemetry channel to bring it to the ground and then wirelessly, over Bluetooth or Wi-Fi, to my laptop. For a video transmitter, I have the new Rush FPV Solo Tank 1.6 watt unit, which I tested in a video released just before this one. You can check it out here. The camera I chose to install here is the Firefly Split 4K one, which I've had for ages but never used because I didn't know what to put it on, and it did prove quite suitable for this plane. Also, due to lack of any other option, I did connect a Neo 7 GPS unit to the F765 wing, but on Maiden Day, the controller just refused to see the GPS unit, which is funny because I also had the Telefly Pro antenna tracker board connected to its TX wire, listening in on those coordinates, and it was seeing satellites and was sending valid data down to the tracker as indicated by the LEDs on it being lit. But the F765 refused to see it no matter what I did. Only started working once I connected a new BN220 GPS unit to it, which had arrived after I finished the build, so Maiden was moved to the following day because of that. And without further delay, here is Maiden Day for the Aggressor. At this point I'm exceptionally happy with my ground station, though there is some more work to be done to optimize it a bit and get it all into a single case, but all in good time. The goal of the day was to get the Aggressor flying. I was thinking of going with a 4S LiPo battery for the Maiden because I was afraid this motor will draw too many amps for my lithium ion pack, but since I was lazy enough not to change the connector on the LiPo, ended up with the 4S 3P lithium ion in the plane anyway. They are both about the same weight, around 600 grams, but at least the lithium ion is 10 amp hours compared to only 5.8 amp hours for the lithium polymer. Plane was balanced almost neutral with a hint of nose heavy, and since I did see some reflex, did not give it any up trim. As usual, checking movement of all control surfaces and making sure the autopilot is stabilizing in the correct directions prior to takeoff. Then, with everything ready, I put on a glove just in case, handed the radio over to my friend so he can flip the switch for auto takeoff, and when he did, I threw the plane in the air, making sure to immediately move my hand down as I'm releasing it rather than back in order to avoid the prop. So all went well. Plane took up with authority and auto takeoff on Arduplane worked perfectly on Maiden flight once again. Just in case you're curious how to set up the Matic F765 wing or pretty much any Ardu based flight controller with Mission Planner, you can refer to one of my videos on the subject here. So, Aggressor was finally in the air, loud as hell, but I gained some confidence in the plane following that takeoff, so once the radio was back in my hands, and the glove off of course, I proceeded to get a feel for it and test it out. Switching to manual mode revealed that it does need some left roll trim, which may be due to some torque roll from the prop as well, but some right roll was present with the motor off, so some trim was needed. I'm curious to test a smaller prop as well, something like 9x8 for instance, to see how it will do on speed tests. Takeoff shouldn't be affected as it has more than enough thrust for that, even when limited to 90% throttle. Also, good news is at 90% throttle, amp draw from battery is a bit over 40 amps, so the battery should be fine. And indeed it was barely warm after each flight regardless of how I flew. Really happy how this one performed. One thing you may notice is some waves in the HD recording. Those are coming from the motor. Seems to resonate with the camera at certain RPM, and the waves come and go away as that changes. I have the prop balanced perfectly and tried to balance it with the motor together, and even with the best I could do at the field, I was still seeing them, but on the second flight they were somewhat reduced. Didn't bother me too much though. Naturally, after sorting out the trim, first thing I did was to test the plane's stow behavior, and sadly this is where things took a weird turn. I was cruising along in fly-by-wire A mode and decided to see how it glides, so throttled down and banked slightly to the left to turn the plane, and all of a sudden plane just rolls over and goes into a spin, and I wasn't even below 40 kilometers an hour, and this thing has a ton of surface area to create lift, since basically the whole fuselage is acting like one large wing, and yet here it was, a tip stow and a spin out of nowhere, and at this time, at this altitude, there was pretty much no wind as indicated by the wing estimation here. So, after recovering it, I immediately gained some altitude, still in fly-by-wire A mode, throttled down and gave it full up elevator to see what will happen. And it turns out that when in stabilized mode, with the autopilot working its ass off to keep it level, you can sort of keep it going straight if you don't bank the plane. I then took it up again. This time I held the elevator up for longer, no banking, but this time it did get into something of a spiral and did not stop spinning when I released the elevator, so I had to apply other methods to save it. Next test was from an even higher altitude, but this time in manual mode, and again no throttle and full up elevator resulted in some form of a stow not long after, but it took its sweet time getting into anything even loosely resembling a spiral, and as soon as I released the elevator it just went straight with no more twisting and turning. But what did surprise me was how easy it was to get it to dip a wing. And as you saw in the first accident, which wasn't on purpose, going into a spiral doesn't take a lot of effort. It does appear though that the autopilot may have something to do with it getting into a spiral when it is stabilizing, seems to do better in manual mode. It also needs to be taken into account that it is balanced very close to neutral, so perhaps a slightly more nose heavy balance will improve stow performance, so we'll have to try this next time I'm out with the Aggressor. Right now I was worried that if I move the battery forward, the plane will no longer be able to gain any altitude. Even with my almost neutral balance, it was not willing to go up quickly. That would have required more throttle, which would have drained the battery sooner, and I was, after all, gunning for distance, not only altitude. As a comparison, the Zocht Drift, which also flew the same day, gained altitude a lot quicker and easier than the Aggressor, and get this, the max altitude I was able to go with the Drift was 400 meters higher than the Aggressor, and this is with a 2S battery in it and a shorter flight time too. So, seems to me, at least with this kind of balance, the Aggressor doesn't really know how it wants to stow, but it does, and doesn't take much to get it there, so keep that in mind. Also, mine is relatively light. I've seen people load it up at least 200 or 300 grams more, and they have complained that it tip stows more easily. So, following this, at least now I knew what to expect in terms of stow behavior, so next thing I did was to head out and start putting some distance between me and the plane to see how the solo tank will perform, and I quickly found out that in addition to the easy stalling, the Aggressor wasn't overly eager to get anywhere fast. To add to that, it was getting nowhere at a good deal of current too. Otherwise, it didn't really gain any altitude either, which made things even worse. I was able to reach to only 14 kilometers, though granted I had done all that testing at the start of the flight. So, next flight I headed out immediately, this time going straight against the wind to make sure that even if I run out of battery, I will have some nice tailwind on the way back, so won't need it that much. Also, that is why I gain altitude during my tests, so I can have safety in that as well and be able to glide back the distance if I have to. If I have to be flying at a lower altitude, flat out and back, I won't be able to go out quite as far in that case because I would need the battery to fly the way back as opposed to just gliding. So, with full battery at my disposal and an average of 30 kilometers an hour against a 20 kilometer an hour wind, I headed out again, and this time ran out of battery at 18 kilometers out, but was only able to gain 2,400 meters in altitude compared to the drift, which did 2,800 meters that very same day in that same direction. Also, the drift had about the same speed going against the wind, or maybe even a bit better, which didn't speak well for the Aggressor. On the way back, I was indeed able to make it with barely using throttle and actually nosediving during the last few kilometers, reaching speeds of around 135 kilometers an hour. And the plane actually felt fine and tracked well, but I can't even imagine how much current it is going to take to make it go that fast in a level flight under its own power. Lucky enough, the day went without any accidents and problems. I wasn't overly impressed by the Firefly's 4K recording. It looks sort of out of focus a good deal of time and not really of a high quality. And I do have the Firefly 6 and the Firefly 8 SE, and I know how they can do 4K, so this was suboptimal, but it was light and convenient for mounting with minimal air drag because this plane certainly doesn't need any more of that. But seriously, they should have named this plane the Lame Duck, not the Aggressor. At least then the name would have given the correct impression of the plane's flight performance. Don't get me wrong, it flies well. Would cruise comfortably at 50 kilometers an hour, though not cheaply in terms of current, and as long as you don't overweight it or slow it down too much, there shouldn't be any issues with tip stalling. It does land easy and can do some aerobatics, but to be honest, I was not overly impressed by its agility. The air loader, of all planes, looks a good deal more lively in the air going through the motions compared to the Lame Duck. I saw some people saying that it is agile, but I just don't see it. Perhaps when set up as a twin tractor it may be, because then those elevons are going to get thrust from the motors directly, which will greatly improve agility, but sadly nothing can cure that draggy body and the huge amounts of current it needs to get it going quicker than 60 or 70 kilometers an hour. Even cruising at 50 kilometers an hour draws more than I would have expected or liked. So, in conclusion, I can tell you this: all planes stow, and the Lame Duck is no exception, apparently. The differences are in how these planes handle the stow. Whether I can make it stow less and behave better when it does will require a bit more testing, so there will be a follow-up video on this topic specifically. Also, adding canards apparently helps with that as well. For the time being, I am just surprised a forward swept wing plane can dip a wing so easily, but it may be a CG thing, and moving the battery a bit further forward for a slightly heavier nose may improve this behavior. Agility can be improved by making it twin tractor for sure, but as for the speed and current draw, sadly, not much can be done to increase the former and reduce the latter at the same time. So if you have this one in a box or want to buy it, keep that in mind going into it. This one is a short to mid-range cruiser and will not be able to take you out to record ranges, and as I already mentioned, if you don't particularly care about the looks, there are a number of planes out there that can get you out to those distances and back cheaper, lighter and quicker. Just in case you want to read more about the Aggressor, its post in my blog should also be ready now, so please follow the link I've put in the description below. There you will also find a lot of other reviews on a number of planes, including some alternative to the Aggressor, featuring a lot of information and high quality photos. In case you found this video interesting and useful, or at the very least entertaining, please like, share and subscribe, and don't forget to click the bell button in order to get notifications. Engaging with this video in any way helps it get seen by more people, which really helps this channel grow. For those interested, I've linked all that I've used in this video in the description below. Those are affiliate links, so no additional cost to you, but it is how I support this channel and my family, so you will have my eternal gratitude should you decide to go through them next time you need to make a purchase. Another way you can support me is Patreon, the link is also there, and I would like to say a big thank you to all the people who have supported me so far in any way and would continue to do so. I wish quick and efficient flights to all, and I will see you in the next one.